So continuing with biostratigraphy, in the late 70s, early 80s, Stephen Jay Gould and Niles Eldredge, who we're going to talk about next time in a big way when we talk about evolution, came up with these rules in biostratigraphy to look at and think about and ponder what's really going on. Are we looking at true fads and lads when we're sampling the rock record? And so for rule number 1, they say that if you are collecting a particular fossil and it is trending, let's say it's getting bigger or thicker or bigger spines or changing color, whatever it happens to be over time, but then those morphologic trends change, they reverse direction, and the organism looks like it's getting smaller and smaller through time, then you shouldn't draw a fad or a lad line. You should say that, well, this is ecophenotypic variation, that there's an environment change which causes this to happen. And so in the photograph right over here, you've got a foram, which is, a microfossil, single-cell microfossil, and it's just sort of an outline of the shape, which, as you can see, it's sort of a cumulative mean of length, width, and thickness. And over time, and over here you've got 10 million years of time, the dots represent data points. You see they're staying relatively the same, but they're getting bigger. There's a period of rapid evolution. We'll talk about that later. And then a change upward. Well, this could be interpreted many ways. Is this one in the orange area one species? So you've got a fad and a lad. Or is this period of rapid evolution, is this just adapting to a rapidly changing environment, in which case you've got a fad here and your lad is up here at the top? But what if you were able to collect and continue to collect, and you see in different environments that this same species, because now we're living in the living area, that you can find smaller ones again in a different region. And if you were able to collect it through time, continue, it went back this way. Well, then in that case, the fad would be way down here, but the lad is still to come. How do you do this? Now, this is up to today, but what if you're collecting rocks in the Cretaceous and the Permian and the Cambrian? You need to look at all your fads and lads, look at these morphologic trends, and then determine whether you've got actual fads and lads or whether there's some correlation to environment. The solution? Collect other sections to either verify or falsify this. Is it truly the last appearance of this creature, or truly the last or the first appearance of this creature? Rule number 2. If you have a species that reappears higher in a strat column, then instead of calling this a lad, the last appearance, you've got to say, well, it's absent for whatever reason, and it might be that it died in that area. It might be that the environment changed. So here we've got these vertical blue stripes that represent some particular species. I can collect it right here by the road, collect it up through these rocks of different types, and then boom, I can't get it anymore. And then you have to go through 15 to 20 different feet before, boom, there it is again. Typically what we'll do then, if this is the same species, and we can easily tell it's the same species, we say that we're going to range through. We're going to draw maybe dashed lines to say that it existed somewhere, but not at this spot at this time. And so this could be due to a whole bunch of reasons, but we range through is the term we use. So there was just a local extinction, a local elimination of this species, and it could just be because sea level got very shallow and this species was not adapted to it. But then once sea level rose again and deeper waters came in, that species returned. Rule number 3, if you have a fad or a lad and it coincides with a change in lithology, a change in the rock type, then that's one of the clearest signals around that you're looking at probably not a real fad or a lad, but just something that's due to environmental change. So in this diagram right here, this cliffside, you've got a particular species represented by this green bar, and you've got a fad right there at that line between that particular sandstone and let's say this silty mudstone below. I would immediately say, well, that I'm going to question that particular fad right there. It's probably something that is related to the change of environment that brought this type of rock, this type of environment here. And then rule number 4, if you have a bunch of fads and lads that all coincide together, and here I've got 3 lads for these species and 3 fads for this one. I even see different rock types here, and not only different rock types, but notice there's flat rocks here and angled ones here. So this is clearly an angular unconformity. This is a huge gap, an unconformity, where we've sort of lost strata. And what you have to do, you collect more sections somewhere else to see if you can fill in that gap. And so it's not a true fad and lad situation. Now, all of these things have in common that they are what we call inductive science. It's not hypothetical deductive science. It is just, we need more data. Get more data, observe more data, run more experiments, whatever it is. And so you can say the sequence of zones that I've created are fads and lads in 100 places. I'm going to expect or think that in the 101st time I collect somewhere, the same thing's going to happen. What we're doing then, we are verifying our previous hypotheses. We're not testing to falsify them like we talked about before. Stratigraphic research, unfortunately, has to be done this way mostly, but realize if you found one section where your fad and lad situation was not the way you thought it was in those previous 100 sections, boom, you falsified. So it's a slightly different way to do science, and just realize that biostratigraphy has an induction style to it. If you're interested in induction, just Google it and you'll find a whole bunch of things. Now, a radical shift in gears here. Here I'm going to introduce a couple other terms, foo and loo. And foo and loo, instead of fad and lad, well, foo and loo are used by some groups. That stands for first observed occurrence and last observed occurrence. Sometimes people say that the first observed occurrence and last observed occurrence is a safer way to go because you don't know if it's the true fad or lad. And I just showed you a whole bunch of examples where that could be the case, that the fads and lads could not be could not be true. So let's call them foo and loo. Well, if that's just the observed occurrences, then there might be strata above this where the fossils still might occur, or fossils below this where this might occur. Well, I'm going to give you a situation here, and I'm going to give you a solution that's been sort of laid out in the recent years to look at this, to estimate the true range. So here's the possible range from, let's say, 10 meters to 50 meters, so a 40-meter range. And I have found this fossil, there's a put little star here, at these 3 spots. There, there, and there. So the total range is from 10 to 50 meters. Well, we've created something called gap analysis to estimate or give us a guess of what the true range might be. So if fossilization is random, that's a big F, but let's assume that's true right now, then the average gap size in each of these fossil occurrences can be an estimate of the gap it's going to be to the next horizon. You see what I'm saying here? So you've got 3 horizons. You've got a 10-meter gap right here, and let's say a 30-meter gap between this one and this one. Well, just the size of these gaps between each of these fossil horizons lets us make a little mathematical game to estimate, well, if I would find another fossil, it should be found how far up here. So we can define D as R sub 0 divided by H minus 1. So R sub 0 is the observed measured range from 10 to 50, and H is just the number of fossil horizons, 1, 2, 3, and that's going to give us this estimate of D, the gap. So just a simple way to do it, D is 40, that's the 40 meters there, divided by H minus 1, 3 minus 1, 2, gives us 20, and so an estimate of where the lad would be, if this is true, if this is what I've collected, then the estimate of the lad is that it might be as far up here as 20 meters up here. Which would say if I were going into the field and I'm collecting in the mountains somewhere and this is the last horizon I've collected it, and I've only had these 3 horizons, that gap, well, I'm going to focus particular attention. Maybe I'm going to spend more hours here. Maybe I'm going to assign more students looking in this next 20 meters to see if I can find this particular fossil again. What if I have more horizons? So I've come back the next year with a class, and we now have 14 horizons. So we have the original horizons there at 10 meters, 20 meters, and 50 meters, but then I've got a whole bunch more. Well, doing that, I would have 40 meters divided by, well, it should be 15. 15 horizons, 15 minus 1, 14, 2.9. Then the lad is just going to be adding 2.9 meters up here. What if I came back and really collected the hell out of this? I got 50 horizons, which then becomes 50 minus 1, 49. So 40 divided by 49, 0.8. That's saying that the lad, or that the extension here on this true range, would be very, very small. So if you increase the number of horizons, if you sort of keep collecting, and find it in more and more places, you're adding confidence to your estimate or your guess that this is not just the foo and loo, but a fad and a lad. And the example I've been giving here has been adding it to the lad, but really it's adding it to, you could do this just as well to the fad on the other side. And so, again, collect more fossils, get more horizons, you reduce your potential for error. And so the gap, the error bars on here are smaller. Okay.